You're welcome.
So I'm Mike Jones, one of your two co-chairs for COSE. Thank you all for coming, both those of you in the room and those of you in the virtual room. I appreciate your participation. We have a full agenda today. We only have an hour and a completely packed set of presentations. So going through the chair slides, and I am starting on time because we are so tight. I wonder if the clicker works. No. Wonder how I advance slides. Maybe on this computer.
In the same
No.
computer that you started them from, there should be like arrows near the bottom of the screen, and I think that the arrow keys on your keyboard will work as well. And I see Brian raising his hand, or maybe just playing with the UI.
I'm not seeing the arrows. I would like to advance the slide. The clicker doesn't seem to work. Ben, where did you think I could find arrows?
I think they're like a chevron type arrow, which
What
I
I'm seeing
remember
on the
being
left of my screen is the participant list. Let's
right.
see.
So then in the
Lock
middle
queue,
should be
mute all, mute audience.
I think you can also, if you click on the slide part and then use your arrow keys on the keyboard, I forget if it's left and right or down and up. I'm pretty sure that works.
The slide, I see a slide list. I'm not seeing the slides on my screen. I'm sorry about the technical difficulties here. I've never used this tool. Has anybody used this tool? No.
Mike, if you want, I can try to share the slides and see if I manage to figure it out. But then you have to tell me next slide.
You're going to have to speak louder, Ivo.
Yeah, I can try to take control of the slides. Not sure if that will be helpful.
You know, I'm sure there's a UI element somewhere to advance the slides. I just don't see it. Hannes, have you ever used MeetEcho to present slides? If so, come sit here for a sec. Thank you. How do I advance a slide? I cannot find it.
Okay, you're not even showing any slide yet.
No,
Let's say which one did status by the chairs, okay?
yeah.
Think,
But all that does is open it in my browser.
that's not right. Okay, let's
Is
see.
there something up here?
Presentation view.
Yeah, let's try presentation view. Ah, now there are arrows. Thank you, Hannes. Hannes Schofening, our hero. This is the note well. Many of you have seen it before. Please pay attention to the note well. There's a set of meeting tips. The most important one, I believe, is that all of you in the room are to join using the light version of MeetEcho, which is the one that looks like a mobile telephone. And you use that user interface in order to queue yourselves so that we are being fair to people not only in the room but in the virtual room. So please do so. Also, you're all requested to scan the QR code or use the tools to fill in the virtual blue sheet to indicate attendance. There's a set of resources that I'm going to skip in the interest of time. Most of you've probably already found them. Per every IETF working group meeting, I need 2 volunteers, or more than 2. I need people that are willing to contribute to the note-taking. There is a shared note space. Can someone in the room raise their hand, or in the virtual room send me a chat saying you're going to be taking notes? And we won't proceed until we have a note taker. Peter, thank you. Others, feel free to join Peter in taking notes in a communal fashion. It's a shared editing tool. We also need a Jabber scribe. There's the Jabber link in the meeting agenda tools, the same place that you found the little icon to join the meeting. Can someone monitor the chat traffic? And again, this can be done in the MeetEcho tool as well by selecting the chat icon. In the chat currently, Mike Perrock has said something, Jeffrey Haas has said something, Evo has said something. That chat is where you would monitor it. Is anybody willing to monitor the chat and speak up if necessary?
Hi, Mike. Yeah, this is Ben. I will be watching the chat.
Thank you very much, Ben, our esteemed area director. We have a very tight meeting agenda. We only have an hour. We have a lot of good presentations queued up. I am now over by a minute. So I'm going to turn it over at this point to my co-chair, Evo, the second agenda item, who is going to talk about the status of current drafts, including the BIS drafts. Evo, do you want me to try to present that? I should probably figure out how to do that again.
Yeah, either you should share the slides, or if you need the slot, I think I'll be able to do that myself.
Perfect, thank you.
Okay, do you
Take it
see
away.
the slides? Okay, thank you. So yes, I'll be presenting the slides. I'm Ivailo Petrov. So yes, I will start with the BIS documents, namely 1952 RFC2B and 1953 RFC2B. So
Evo, you should get closer to your microphone and speak louder, please.
Oh yeah, sure. So basically, Ben Kaduk has been spearheading the discussion with the RFC editor. There has been a number of exchanges, and most of them are already closed. The important part is, for me, a question about whether we need to require private key in key operation values. This is table 5 in section 7.1. Maybe it would be best first to present all the slides and then come back to this question if there are any comments from the participants. So this is the most important question for me that we could discuss today, because this is not exactly consistent with RC 7517 and with W3C's web crypto. And we are claiming to be consistent with those. And then there is a reformulation of this sentence where Ben has indicated we might want to check if this still makes sense to everyone, whether the formulation is still good. My personal individual opinion is that it seems fine, but yes, if anyone has other opinions, we can discuss that further. And Yeah, going forward, so then there were some comments from Karsten, and the first one has already been addressed. There was some text that didn't make sense in its uh, state, but yeah, now it's fixed. Then there is an update that was done in 1952 and not in 1953 document, so we would need to make them consistent. And the last point is suggestion to not call CDDL a grammar, but rather a standard definition language for Seaborg data structure. All of those make sense to me individually, but we can discuss if there are other opinions. And yes, going then to the next discussion item, Karsten was suggesting to be more precise when we talk about deterministic encoding requirements and specify which section we are aiming for. And yes, this is the text that he has suggested. And so that was for the BIS documents. And after we have resolved those couple of issues, we need to check for consistencies between the two drafts, and they should be ready for publication. Then for the hash aux draft, I answered to some questions from the editors, and my understanding is that now Ben or some other AD needs to take a final look and say that it's good for them as well, and then it will be ready for publication. So next, the X509 draft. We are going to publish a new version of the draft, and that was discussed some time ago, and there is an issue 31 that I believe we should get some more discussion on. I saw that today, like maybe an hour ago, there was also some discussion for a new issue. I have not yet dig deep into how it might affect the draft. So then the countersign document, as far as I saw, it's with Roman and awaiting KD review. It's in publication requested status. And going then to CBOR encoded certificates, my understanding is that there are more reviews that are needed, and there are some small to-dos that are still pending there. So that's all the drafts that I wanted to present the status of. Now we can go back maybe to see if there is any quick opinion on this required private key fields text, or maybe we can start a mailing list discussion otherwise.
And in my role as timekeeper, this is the 1-minute warning. Hannes will take over in a minute. Are there any questions for Ivo? If so, cue yourself. Otherwise, I will cue Hannes's draft and we can start on that.
Okay, thank you. You can also write in the mailing list, of course, if you have some comments.
Okay.
Thank you.
Yeah, that's what I'm trying to figure out. Meeting materials, that might be it.
Does someone know how to?
Eva, do you know how to share a deck?
Oh.
How did you do that?
I don't
Maybe
know.
Eva did it. Thank
Yeah,
you.
it's,
Take us away, Hannes.
Okay, perfect. Yeah, thanks. Thanks a lot. So briefly talk about the COSE HPKE document. Next slide. Probably Ivo needs to do that. So we had a fruitful discussion at the virtual intro meeting in January, and I published a 0.1 version in response to those discussions, and I will show the most important change with 0.1. I also created, as I promised, an implementation, a reference implementation of this, which you can find at this link below. It's the DCOSE library. And here's also the link for the draft repository. Next slide. So this is, next slide. So this is the new structure. If you haven't been following the discussions last time, so this is a two-layer structure. At the top, you see the sort of classical encryption sort of headers. In this case, the ciphertext is not included, it's detached. There's the algorithm information in there in the topmost part, and also the nonce. And then the recipient structure, that's where the HB key content goes in there, with obviously the ephemeral public key. And then finally, with, in this case, with the encrypted KEK, which is the KEK is used to encrypt the outermost plain text. Okay, so that's what's currently in the document. It's a big change compared to the previous version. Next slide. Okay, the open issues. So we talked about the algorithm registry, and the group wanted to have an efficient way to reuse the HBKE defined algorithms. And obviously for the currently defined algorithms, there isn't really a problem because they are listed in the now RFC, and we can just, well, they will be put into the document and registered. But the question is, what happens going forward with new algorithms? And we discussed primarily the first approach, which was to add a rule in quotes to the HBKE specification to then automatically populate values in the COSE registry. Unfortunately, shortly after the virtual intro meeting and the discussion, the HBKE document was published as an RFC, so no changes were possible anymore. Which leaves us with two other choices, either to have a rule with IANA to sort of automatically populate values in the registry, which in my opinion requires some discussions with IANA to make sure that this actually works. Some folks in the group were hopeful that this is simple to do, but I don't know. And if that doesn't work, the last approach is obviously, or this approach is sensible to require that whenever someone defines a new HBKE algorithm or cipher suite, then they need to also populate the registry for the corresponding COSE registry. So that's kind of like nothing really earth-shaking, but at least there was a lot of discussion on this topic on the list.
Ernest, do you want to take questions now, or?
No, go ahead.
I am Ben, please go ahead.
Yeah, so I think there are definitely some cases where IANA will be able to say when there is a change to one registry, go and reflect that in another registry. But you're right, you should definitely talk to them about this particular case because they really want it to be a very deterministic algorithm that they follow. They don't want to have to use any judgment. And I believe they have office hours this week, but it's probably only in GatherTown. It may not be in person. The other option that you can do is to have the registration policy for the COSE specific parts involve a designated expert, and then basically give the experts leeway to say whenever there's a new addition to the other registry, they can just make the new registration in their role as experts to approve it.
Yeah, yeah, we'll definitely use the IETF meeting here. In some sense, it's a pretty simple task. The COSE, the HB-key registry consists of 3 separate registry: AAD ID, KDF ID, and CHEM ID, as I wrote on the slide. And in COSE, it's just mapped to one number that combines the 3. Well, well, you could call it simple or not, I don't know. But in any case, there's something that needs to happen. It's almost like a CI in case you you make some changes, then it automatically does something else. But yeah, so yeah, I don't know if someone has some better ideas what to do. But the first option that we discussed and preferred at the intro meeting is kind of gone, unfortunately. That's what it is.
So I think the second one will work pretty well, and I would suggest that we just keep going in the slide deck.
Yeah, okay, perfect. Thanks, Ben. Next slide. So that was another point that Ilari raised that was briefly touched on at the virtual intro meeting, but there was no conclusion or no feedback, and hopefully I get some feedback from you. And Russ was kind enough to reach out to some guys in the industry to get an understanding of where we are in terms of state of the art. So this is about point compression. And currently the previously shown example with the ephemeral public key that was included in the structure in the recipient layer, that's an uncompressed point, and point compression would obviously help to transmit fewer bytes on the wire. And it turns out that this is a 20-plus-year-old technology, and the idea is to, and that was what Ilari was suggesting, to add that capability to the document as another point format, being optional because it's not necessarily widely supported everywhere for mostly patent reasons. And so, yeah, I think to me that makes sense, what Ilari was proposing on the list. I don't know if anyone has some opinion here about this topic or has some experience with point compression and this and the like.
Yes, Russ, please go ahead.
So my discussions with some implementers were that there was a lot of code that cut to implement point compression. And in small devices, it would not be desirable because you have to add a square root function that you don't otherwise need. And so the code gets much bigger. So they were opposed to making point compression required. We'll see what other people think, but at least several implementers said that's not what they want to do.
Thanks, Russ. Yeah, Russ checked out with people, so yeah.
At the microphone, please say your name.
Yeah, Malish Učenić, Indria. So just the data point for the data compression. I was just working with the point compression for the past 2 weeks in the context of the ad hoc and lake implementation. And it is true that it is poorly supported in the existing libraries, but there is the RFC 6090 algorithm that doesn't require the implementation of square root, that can be implemented with the pure module operation, and that is fairly simple to implement from my experience. So this is well needed in the context of constrained technologies, in the context of bytes over the wire savings.
Yeah.
Thank you. Could you go show Peter your name badge for the purposes of the minutes?
Okay, 69.
1 minute warning.
Okay, thank you. Next slide. I will skip that one. Next slide. In interest of time. So this is a change I'm proposing. So the COSE specification has for all the different operations, it constructs additional data or additional information to be included in the whole processing. And so regardless of whether you use a sign operation or in this case an encrypt operation, and that's this information is also structured as a COSE sort of data element. And currently what's in there in the document is also an infrastructure to be used with HBKE. And initially when it's a leftover from the early days of the document in the suit group. And HBKE itself has its own way to pass information into HBKE for inclusion into the key derivation. And so in my opinion, that infrastructure is not needed in addition to that. So since HBKE already provides, uses its own mechanism and provides addition for someone who wants to pass in additional information can do so for certain usage environments. But so I'm proposing to remove that infrastructure from the document. It's probably something to digest for people who are following these type of mechanisms.
We are at time. I'm going to have you take that question to the list.
Yeah.
I will recognize Militia Vucinic on the queue, and then we'll switch presentations.
Militia, do you want to, was that from previous, from the previous thing? Okay.
Okay. Thank you very much, Hannes.
Yeah, bring that to the.
And do engage with Hannes on the mailing list. So the next pair of presentations, I am not the chair. Ivo is the chair. I am an individual contributor to two documents that my colleague Tobias Looker in New Zealand is the primary author of. But it is exactly 12 hours time difference, and so this was not a convenient time for him to present next. So there's a set of elliptic curves called BLS that belong to the realm of pairing-friendly cryptography. And there's related work underway at the CFRG. There's been some discussion of this on the mailing list already from Russ Housley and the like, and I'd like Russ to comment at the end if possible. So this is used by a number of different pairing-based operations. All this draft does is register Jose and COSE algorithm identifiers so that these can be used for COSE and Jose. It does not define any cryptographic operations. Next. So there's numerous applications of pairing-based cryptography. There's one called BLS signatures. There's the BBS plus signatures work that some of you who are aware of some of the current decentralized and zero-knowledge proof work may have been following. Again, this is supporting other work in other standards organizations, but Jose and COSE have become the gold standard for respectively JSON-based and CBOR-based cryptographic operations, which is why Tobias is bringing this draft to this working group. There's also ongoing work on something called JSON Web Proofs that I'm a co-author of for doing JOT-like and JWS-like signatures, but with multi-signature and zero-knowledge selective disclosure proofs. Next. So the only next steps that the authors are requesting today is for people to read the draft and to comment on the mailing list. Following a discussion on the mailing list, depending upon how that goes, we may ask for working group adoption, but we are not doing that today. I would invite Russ to speak to his comments on list about the charter of this working group and what we may and may not do and the relationship between this work and the CFRG work cited, if you are willing to do that, Russ.
I'm not opposed to seeing these code points. I think that's the most important one, no matter of how we get the document.
Russ, you're too quiet for us to hear. Can you yell into your microphone, please?
I'm not opposed to the points you're proposing, as a matter of making
And the chairs can take that up with the area directors, et cetera. And Eva and I will take that action item with me wearing my chair hat and not as a draft author hat. Unless there's questions on this, I would ask you to read and take it to the list, and let's move on to the next presentation. This is another one that Tobias wrote. In response to a real need seen, among other things, that came up during, I believe, the development of the New Zealand COVID credentials, which do use COSE and CBOR Web Token formats. So here that we're having adoption in the healthcare space. Next slide. So we all worked on, or many of us worked on CBOR Web Token together. We worked on COSE together. The JOT spec, which came before, has an interesting feature which Dick Hart had requested and some others based on practical experience, which was Dick was looking at if you have an encrypted token with JWE, you obviously can't see the claims. That's generally a good thing. But sometimes when you're processing a token, like routing it, trying to decide where it goes, you may want some information from the claims to be publicly visible. And so section 5.3 of the JOT spec explicitly sanctions you repeating claims that are not privacy sensitive in the header parameters. In particular, the issuer claim has been repeated in some contexts in encrypted JOTs to help retrieve the key set that you need to even do the decryption. That's worked out okay for JOTs. It does not, that feature is not present in CWTs. And furthermore, you couldn't just port the feature directly into CWTs because CWT claim names and COSE header parameter names are both small integers with an overlapping space. So you couldn't just mix and match. Next slide. So the proposed solution in this draft is to define one new COSE header parameter, the value for which is a set of CWT claims that can be disclosed in the integrity protected but non-encrypted header. This parallels the JOT functionality that's already been shown to have at least been good enough to solve the problem at hand. I think that should be fairly clear. Let's go to the next slide. It is exactly the same as the last slide in the previous presentation, where we are requesting that working group members read the draft, comment on list, and depending upon how that discussion goes, the authors may ask the chairs for working group adoption, where I will obviously stay out of that as a conflict of interest. Any comments, or can we move on to the next presentation? Because I think we're even a minute or two ahead. The next presentation is by Mike Prorock, who's remote. Evo, could you queue up Mike Prorock's presentation on post-quantum signatures? And Mike, are you with us?
I am indeed. Hopefully you can hear me all right.
That's good. Thank you. Please proceed.
Awesome. Thanks so much, all. And we can jump right into the next slide here. I authored an individual draft and then got some great feedback and support from a number of folks, as well as contributions. So, and some folks also obviously working across other aspects of cryptography. So we've got basically the problem statement is this. We know post-quantum algorithms will come out. And from a day job perspective, I do a lot with signatures, and I wanted a way to be able to interoperably sign things with post-quantum methods and make sure that the other side was interpreting that correctly. And that's with both Jose and Cose. So we wrote up the draft. Initially, we focused on kind of two aspects of post-quantum signatures, so hash-based and lattice-based schemes. The main reason for that is that we want to make sure we have a good trade-off and good options in case we find problems either with size on signatures that just make them impractical, or key sizes, or if we find a weakness in one approach, be it a lattice-based approach that has some fundamental weakness that we're not aware of, we want the ability to fail over to hash-based or otherwise, right? So it's really about providing crypto agility. The main concern I see is that the NIST standardization process is obviously still ongoing for this, but these algorithms are out. They've been around for a while. They're, I guess in what, round 3, and are, moving forward there. So I think even if NIST does not standardize one of the algorithms that we define here, we would still want to um, go ahead and get it defined, if for no other reason than to be able to make sure that it is defined and we can flag it as, hey, please do not actually use this from like an IANA registry standpoint. Next slide, please. So, once again, kind of going back to the main goals, we want to really enable agility to be able to jump up to these post-quantum algorithms when they're appropriate. We want to be able to test ahead of time. And then we do want to go ahead and make sure that we can get IANA registrations done for these post-quantum signature schemes. Otherwise, one of the things, especially due to the high level of parameterization and the fact that most of these algorithms get their security properties from specific combinations of parameters, we want to make sure very explicit parameters are registered for each algorithm so we know what's good, what's bad, et cetera, right, and can put that out. Next slide, please. Some complexity in getting at really kind of getting at the parameterization side of things, right? We really need to be able to use ALG or some other identifier, right, within there, just to make sure that we can clearly identify what set of parameters is in use, for instance, with dilithium or Falcon, or especially with Sphinx Plus, et cetera. So we do want to make sure that that's very explicitly stated. Otherwise, it'd be very possible to either misidentify a key or to run a method or a signature method with the wrong set of parameters, and that's obviously not good. Next slide, please. So next steps for us on the individual draft side is to go through, really continue fleshing out the algorithm descriptions. We've got a good baseline in place. We're looking at, as a group, that are working on it, some different ways of just talking about, like the sign verify operations. We're not defining any new cryptography here, like no desire to do that. This is just pointing back at the well-defined stuff. For right now, we're just pointing back to the papers, and that may just stay that way. Um, we are, based on feedback on the list, looking a little broader at some other hash-based signature approaches, especially some more stateful ones. And then we're getting ready to start into a whole bunch of test vector generation, and getting into some better serialization examples with both JWK and with JWS. So really the big ask for the group is go ahead and read the draft. I know quite a few of you that I see here have already done so. Provide feedback, and then if appropriate and if in line for the charter, we'd like to be able to get this adopted as a working group item and move it forward when the time is right, assuming that it matches the group's needs. So thanks so much.
All right, I see Brendan and then Jonathan Hamill on the queue. Let me take Brendan first.
Brendan Moran here. I just wanted to point out that there is already a point in COSE for one of the hash-based signature schemes. HSS LMS has a reference in RFC 8778.
Thank you. Jonathan?
So, yeah, I would just want to point out what I pointed out in chat, that the algorithms, according to the COSI Charter, have to be evaluated by CFRG or completed public review and evaluation by a process such as the NIST process. So, if these algorithms that you're defining here are not selected by NIST, I believe they would have to go through CFRG evaluation.
I believe that to be true. Is there anybody else on the queue? All right, if not, I will speak. Oh, there we go.
You have
Now I
three.
can see the queue. Andrew, please proceed. Andrew Frigley.
Sure. I just want to note that the HSS, LMS, and XMSS are actually all approved NIST algorithms post quantum. If you read NIST 800 SP 208, you'll see they're approved there.
Do you have a document you could reference in the chat for purposes of the
Yeah, I'll
notes?
put that in the chat.
That would be fabulous.
People don't realize they're approved because they weren't part of the competition, but they're acknowledged by NIST to be post quantum. So I'll put that in the chat.
Okay, very good. Benjamin.
Yeah, sorry, I guess I jumped a little bit too early with sending my video, but I mainly wanted to just say thank you to Mike for the, to Michael for the bit about reducing optionality and really nailing down the parameters for the post-quantum stuff. And it'd be really useful to have these sort of just use this and not have people worry about exactly what they have to choose.
Agreed with that. Emmanuel.
Hi, can you hear me?
We can.
Okay, thanks. Yeah, thanks a lot. It's a very interesting draft. I think it's might become like in my mind like two drafts in the sense that what we do with Jose, what we do with Coses might be slightly different in the sense like they're targeting different use case, at least in the very constrained case. Some of these signatures might be less appropriate than others due to their size and things like that. So maybe clearly separating this use case of very constrained devices might make sense. Maybe there are some things that are really can be said as maybe less interesting in this context of very constrained devices. I talk on behalf of the committee working on the Riot operating system, where we have like very constrained devices and microcontrollers and things like that. I know some of people in the room are, are very sensitive to these types of constraints. But yeah, that would be great. Actually, we have recently published paper on this that is analyzing some of these signatures in this context using COSI for a suit security for updates on Riot devices. I can share the link if that's interesting also here.
Yeah, indeed. Please share links for any relevant things for the minutes to the chat to help Peter out. That would be great. Mr. Prorock, you have the cue.
Going to note there's a related draft, and actually, can we pop to the next slide? I think I put a link reference in there, and I'm going to dig up the link and put it in chat. But this is actually also highly referenced and has a number of the folks that are also working on the key information spec as well. I'm linking that now. So there's quite a bit of overlap there, just in terms of, yep, we already know that these things are getting well defined. The keys are going to be well defined, and now let's make sure we can do this with, compact binary representations as well as JSON representations as appropriate.
Appreciated. Emmanuel, you have the floor.
Oh, it's just a leftover. I think I said what I needed to say. Sorry.
Okay, I'll make one closing remark, which is COSE as a working group is chartered, among other things, to do registration of algorithm identifiers for algorithms with a certain level of maturity. We are explicitly not chartered to describe new kinds of cryptographic operations. And there's a fairly bright line between the two. I will say, just wearing a hat as an individual right now, when I read the draft at first, I know that there was a lot of explanatory text trying to say how these algorithms work and how they might be used. I don't think that was intended to be normative, but some readers could think that it was, where all the normative components should come from the authoritative sources. I'm not suggesting a particular action other than think about making sure that the draft stays on the right side of that bright line in our charter, because otherwise you'll run into problems with reviewers later. Are there any other comments on this? Otherwise, we will switch to the last presentation, and we are running a few minutes ahead of schedule. All right, thank you, Mike, for writing that, and thank you for all the feedback that's already come on the mailing list. Please keep it up.
Hello, can you hear me?
We can maybe speak a little louder.
Right, can you hear me now?
Yes, that's better.
Okay, so hello everyone, I'm Göran Selander. I'm going to talk about this really short draft who's been updated today on extending key identifier to integers. Next slide, please. So this is something we discussed on the mailing list between the two previous meetings, and it's addressing the use case when you have really tight message size constraints and you would like to use very short key identifiers. So the COSE parameter KID, key identifier, is currently restricted to byte strings, and CBOR byte strings are typically 2 bytes or more, except for the empty byte string, which is a very special identifier. And in order to allow more 1 byte identifiers, we propose to extend the KID value type to ints, CBOR ints, which have of the order of 50 1 byte identifiers. So that's the proposal. It's a short draft. They're essentially updating 3 registries, and that's a little choppy. Can you hear me now?
We can hear you, thank you.
Okay, Ben had some problems with the audio. So I think this is the last slide. I think the proposal is fairly clear on the slide. Ask questions otherwise. It's basically extending the value type for KID, for the occurrences of KID. We had a discussion about pros and cons for making this a separate parameter and whether this was really needed. And I think the conclusion was that this was how we should do it. And I'm happy to have any comments or questions. Okay, there's a couple of people who have choppy audio here. I don't know if there's anything that needs to be repeated. Still possible to understand. Okay, good.
Ben is in the queue. You're recognized.
Yeah, so I guess this is my fault for not having actually read the draft. I do agree that reusing KID as the parameter instead of defining a new parameter is useful. I just want to make sure that the draft talks about like the deployment considerations for when it is actually safe to use the integer form of it. Because if you just have an updated sender that starts sending it without indication that the recipient will be able to do something useful with it, you will get a loss of interoperability.
Yeah, that type of consideration isn't currently in the draft, but we had the discussion at the time, and the general feeling, if I remember right, was that since this is CBOR, and if you have implemented CBOR byte string, you typically have implemented CBOR int as well, and these are typed. I mean, CBOR has built-in typing, so you would typically, of course, you would notice that there is an error here if you expect the byte string and you get an int, but you wouldn't it wouldn't result in any that you would get sort of the wrong type of value. You would get the wrong. You expect a certain string and you get an integer instead.
Right.
But I think that type of deployment
would just be a very clear error. It would not be misparsing what's there. Yeah.
It would be basically detecting the wrong CBOR type, and that would, of course, if you can't support the int, that would lead to a fatal error, of course.
Right. Okay. Yeah, I mean, I think that having some text in a document will be good eventually, by the time we get later on into the process. But that's all I have to say.
Yeah.
So I will leave the queue.
Thank you. We'll make that update to the next version. Other comments? Okay, thank you.
I've been waiting to the end. I'm not speaking as a chair. One thing that I think should be explicitly said in the document is that presently all RFC 8152 COSE implementations would be required to reject a data structure with a numeric key ID. There's a data type defined for key ID, it's bstring. And so if you have a conformant implementation and you encounter something that uses a mismatched data type, it must be rejected. Therefore, this is a breaking change. I am certainly willing to leave it up to the working group whether to make the breaking change, but it needs to be labeled as such because no 8152 implementation may be allowed to support it.
Right, that's correct. But
okay.
Specifically stress that in the update.
All right. Is there anything else you'd like to say, Karen?
I'm happy. Thank you.
Okay, thank you. We unexpectedly have 5 minutes of time, which I will now have open mic time on any COSE-related topic. Join the queue. Ben, you are in the queue.
Yeah, I had taken some notes locally about the point compression presentation, but didn't get to say them earlier, so I'll go back to that now. About the optionality of it, I think that this is very likely to be something we would want to only be optional. I think the arguments about making it required being potentially problematic carry a lot of weight to me. The other topic that comes up is about like the relationship of the point format to the curve. And so like currently we've got the octet key pair, which is used by like the X25519 and whatnot, the CFRG curves. And we've got the EC2 point format, which is the traditional uncompressed point format that's used by like the NIST curves. And so if we start trying to bring in new point formats that are using compressed points, we would want to think about how we're going to signal that, and if the intention is to be able to use both EC2 and this new compressed point format on the same existing curves, we might have some situations where it's hard to get interoperability, or it's very complicated to reason about. And so we might potentially, and I haven't thought about this very hard, but we might potentially even like define new curves that would use the compressed point representation as a way of having a clear signal that the different implementations are able to support it. And that would potentially reduce the risk of interop issues. And I guess I will yield to John and get back into the queue for my other topic.
I recognize John.
Hi, I'm very can't see me, but I hope you can hear me. I think it should be optional. I don't know exactly what was discussed, but I think it makes sense, as Ben suggested, to register a new IANA code point or compressed format. Uh, it was discussed during the HPKE discussions, but not really compressed point format, rather uh, compact representation. Uh, I don't see any benefits of using compressed point over compact representation. I think the most sense would be to register compact representation in the HPKE register and then use that in COSE.
Thank you. Ben?
All right, I'm back. I've been Kaduk, and this one I'm more as the responsible AD, at least for a couple more days. There was a question about whether the BLS algorithms would be in Charter, and I think given the ongoing CFRG work, it seems fairly straightforward to say it's in Charter for us. Obviously, if the CFRG work gets abandoned or something and it doesn't complete, we would not want to go forward, but I think it would be reasonable to do what we currently have.
Okay, I appreciate that determination, Ben. That helps some of the individual authors make progress. Seeing it that the queue is empty, I'm going to make a personal statement thanking Ben for serving as a security area director for us and many other working groups, and it's been a pleasure working with you. And if people agree with me, maybe congratulate him in the chat and thank him. Our time together is drawing to a close. I appreciate the productive session. Going once, going twice. We are adjourned. Thank you, COSE Working Group, for your participation. I can certainly try.
I don't know if I join it now, if I'll be able to see the historic chat.
I think you can.
Okay, let me go see if I can do that.
But let me see if I can save it. Got it all. Let me know if you can get it, otherwise we'll send it to you.